Okay, let's have some fun making this assembly. We will start with the color part that's at the top. And so we'll copy that file name, making sure that we are in chapter 14. You can see here, this is problem 14.0 within the chapter. And so if I just do a new object here, accidentally selected that. And we're going to make a standard part in English units. And it's going to be in inches. So we can go ahead and save this one just to get the file name and file structure properly there. And so there's the name I just copied and pasted. And so then we start our new sketch. And I'm just going to select this plane and draw that random shape that we see right over here. So we're going to take that shape and revolve it around. So maybe we could start with a straight line over here and then make that in that first line right there actually be our center line that we rotate this shape around. And so that length right there needs to be 1 1/4. So that's a good place to start. Then drawing that shape right above it using a rectangle tool would probably be good. Just do a 2-point rectangle. Make sure it locks in right there. We could do another 2-point rectangle right here. And then I guess we can do a split on our diagram. Let's see, where's the split at? Is that it? Let's trim, extend, there's split. So we can do it right there and right there. And the reason we want to do that after hit escape is to turn that into a construction line and this into a construction line. And for some reason, it didn't do that when I clicked on it, but that's okay. So now we have this shape right here. We can put our dimensions in. 0.25, and let's see. We can start to use this inner diameter. We see it way over here. Now this right here is a chamfer that we see. So let's first of all do the inner diameter right there. And you can see that's going to be 1.5. And then the outer diameter is going to be 2.5. And then there's also going to be a distance from here to there of exactly 2. Now, I wonder why it's not completely defined. It's probably that this line right here, if it escape, is able to move over, and probably the same for these over here as well. So what we want to do is line this one up with that endpoint. So I guess maybe to do that, if you're looking along the y-axis, escape here, hit the y-axis first, then hit this point and that point, and then hit this point and that point. Now we're fully constrained. Should it be that easy then to go ahead and revolve this and finish it? So if we say finish the sketch and revolve that shape, is that all we got to do? Almost. We want to put that chamfer in there as well. And you can see it's 45 at 1/16 of an inch. If you look at where it's located, it's right here. So it's on that shape right there. And we hover over until we find chamfer. Let's see. It's better when we go full screen with this because you can see it right here a little bit better. And just make sure it's 1/16. And go ahead and save that one. And we got one of the parts completed. Now let's bring this back over here and make the next one. Let's look at the bearing. Still going to be a standard part. We haven't got to the assembly just yet. So file, save as, and we can go ahead and put that name in there. Excuse me, ahead of schedule. And you see 3 circles right here, and then 2 circles here. You see a lot of things there. So let's get it started. New sketch. We'll start on the bottom this time and just draw a bunch of circles. Maybe we can do the dimensions as we're starting. So if you look at that middle circle, it seems to be 1.5. Then you look at the circle outside of that, and it seems to be 2. Then you look at the circle outside of that, and it appears to be 2.5. And then you see that there is a circle up here It's got, I think this is going to be called an S face right there. I wonder if it'll let us do that as an S face. We'll try to do that. So let's put the diameter of 3/8 in there to begin with, and then I think we can do a 5/8 spot face. We're going to learn about that. So there's 3/8, and we need to place that a distance of 3.5 divided by 2 from our origin. 3.5 divided by 2. You see that right over here. I'm not really sure why it's not completely defined. Most likely it just still doesn't seem to know where it's at vertically. That would be my guess. But if we don't know, then we just hit right click, show degrees of freedom. It says something about this rotating here, so I'm not really sure why that is still undefined. Um, oh, it thinks this can rotate around? Okay, so let's just assume that it's not letting me move it for some reason. And you look at X down here, which is horizontal. Maybe we can click here and there, and that was it. So even though I couldn't drag it around, that has appeared to be the problem. I'm going to try to then go down here and do the same thing. And then I'm going to say, let's let this one right here be equal to that one. And then also the dimension from there. Well, I guess from there to there, we can put that one out there just because it's in the diagram, 3.5. And of course, it's confused about where it is horizontally. X is this way. If you're confused about horizontal, just do it like that. And then we just say horizontal like this and like that. And we have a fully defined part. Now from those, we have some circles that go out here. We can either make them arcs or um, we can make them circles that we can just trim. I'm going to start with arcs and just put some out here and out here. Then I can connect this one with somewhere over here, and I like to make it purposefully left wrong. Now that one was horizontal, so that's not a purposeful random line. That's more what I'm talking about there. You want to avoid any kind of constraints going in because you want control over those constraints. Making the radius 3/4 of an inch for this one first. And then you can say that that radius right here should be the same as this one. It also made it the same size. Then we can start doing our tangent like this until we get all of the unknowns known. Let's see, maybe it's this one and this one. Okay, I think I got it fully defined. Now, it does say something about one more dimension being known, so escape, or unknown rather. And we could say, show all degrees of freedom. And I don't see any there. So I'm not sure what this one dimension that is needed because I'm not really seeing anything that's not needed in this diagram. Usually you see some purple lines or something like that. There is something called auto dimension, and we can try that to see if we can figure out what the issue is. And it says one dimension required, and it's something about a curve somewhere. So let's look very carefully and try to say apply that one. And I guess it got confused about something about this. So let me make sure that I put this and this. I did. And make sure that I did this one and this one, and I did. But then why would it have issues with what it thinks to be a circle here? Hmm. Mystery. So what I ended up doing was deleting that line and putting it back in, and now I have it fully constrained. So sometimes you got to do something like that if you cannot figure out where the missing part is. We can begin our extrudes by starting on the outside. So let's go to extrude, and let's just work on this one and this one. And you can see up here that those should be a half. Now, was tempted to press enter right there, but I want to go up and now do this outer one right here. That would be this ring. And we're looking at that and it looks to be 2 inches high. And then we can go to this inner ring right here. Oops. Okay, I wasn't supposed to do that. I needed to hit plus first. So let me clear that out and just do this one. And then I had plus, so I can do this one at a different distance. And you can see that basically that's 2 minus 0.25. So it's the whole distance 2 right here minus this 0.25. Like how I can do the math for you. And it looks like I'm seeing some fillets right here, and it says rounds and fillets are 1/8 of an inch. So let's see, where's the fillets at? It's always difficult to find the shapes of those. I don't really see it, but if you go out like this, it makes it easier to see that. There it is right there. It's probably staring right at me. And 1 divided by 8 is, the 0.125. So we'll put it there and there and look to see if there's any other place we might need those fillets. I don't see them. Oops, I think we need them here too. All right, like so. Okay, Mr. Mackey. Um, I think that's about it, except for this little recess part there. Oh, and there's a hole in the side, of course. Okay, so where should we start? Let's just start with those recesses that are here. And they go down an eighth, and they're 5/8 inches in diameter. We could try to use um, our hole wizard and just try to do that. So if I right click here and say, let's make a new sketch here. When you want to use the hole wizard, you have to place a point where the hole is going to be, like that. See if I can get it to lock in. There it is. And then you go over here to the hole wizard, and it's going to identify that those are there. And then you put all the details in here. The one we're looking for looks like this. And so we put in the various things like 3/8, and then up here, 5/8, and then right here, 1/8. And so that kind of, makes it standardized. It does both of them at the same time. We could have done a circle there and done a cut on straight down, but this gives me an opportunity to show you the hole wizard. All right, let's cut this in half and drill one hole through the middle. So, or through the side of this wall, rather. You know how to do this view. Let's do half section view and then just pick a nice plane that bisects it nicely like this one. Click the green check mark and let's start drawing on this plane that we found. This one right here. This is the, which plane is that? That's the XY plane. And we're just going to drill a circle somewhere in here. And so the radius of that circle, or maybe even the diameter, is going to be 3/8 for the diameter. And as far as placement goes, it needs to be on the vertical. Let's see if I can move it to the right. Oops, hit escape. Can't seem to move it. Oh, yeah, I guess I can. All right. So then if we're looking at the y-axis, vertical is here. So midpoint, that would be good. And then looking at how far it is relative to the bottom, we know that's 1 1/4 from our diagram to the right-hand side. Okay, at this point, we can go ahead and do our extrusion cut. And let's go ahead and cut all the way through. And it doesn't really matter to me, as far as I can tell, which way we do this. Just make sure we go through all. And when we come back to this view, we can just delete that half section view and we have our hole. So make sure you save that one. And now we have 2 parts of our assembly. We could play around with the assembly and get ahead of ourselves if you want to. So now we can go down here to the assembly in English also and create. And one of the things we want to do here is probably place, oh yeah, I'm sorry. We want to put this plate down first. Okay, so that's the base plate needs to come first, so we will start with that one really quick. All right, so I'll leave this assembly open. We can give it a name, as we see right up here. File, save as, save it in that same chapter 14 directory. Let's get down here to the base though. We need to make a new part. And standard. And I'd like to go ahead and save it with the file name right away. And then begin our two-dimensional sketch. Probably on the side is good. And then just a bunch of rectangles, right? So maybe the center rectangle would be the thing to choose here. A slab, like so. And then we look at the dimensions of that slab, and we see that the whole width of this needs to be 7 inches. So it's a big slab. And then over here to the left-hand side is basically the thickness that we have in the middle of it. And let's see if that's going to be clear, what that is. You know what? It says 1/2 typical, 1/2 inch typical. So I'm assuming that all of it is 0.5, like that. That's probably a good assumption. And then what we can do is maybe do like a corner to corner rectangle. So we have one right here and then one over here, making them intentionally wrong, of course. And then we can say that, you know what, this distance right here is that one right there, right? This one and that one, because that 1 inch is going around the whole thing like that. Now, as far as how high it goes above the surface, we know that it needs to be from top to bottom 2.5 inches. But that's probably not enough to make it fully defined, because if you grab this, you can see that you don't really know which way it goes. I'd imagine that this would be symmetric. Let's just see that if it is. It does say that it's 1.5 inches from there to there, so we will assume that that's what we need to do instead of maybe making it symmetric. So there we go. And then we say 1.5. Does that make it fully constrained? Sure does. Let's put the width in there of 3 inches. And we'll notice that we don't really have to put, turn these lines right here into hidden lines. We could just select all 3 of them and do a bidirectional extrude, make it 3 inches. So we don't have to always convert visible hidden lines to visible lines, as long as we're okay with selecting multiple parts like that. We'll start a new sketch on the top just for these 3 circles. Maybe a good idea though is to go back to that practice of making a hidden line right here on the surface. This is going to make everything easier to line up, especially if you lock this one in to the midpoint. And I'm assuming that that's the midpoint, right? Okay, now I can see it's green right there. And this should be fully defined still with the circle. This one's going to be 1.75 according to the diagram. Now we can click on it, turn it back into a real circle, and drill that hole. But while we're here, why don't we just drill the other 2 as well? So let's put a hole right here and another one down here. Let's make those 3/8 of an inch. You can also see that they're threaded, excuse me, which we might get to in just a moment. So let's go like this. Might even wait till the end to thread them, just because we're kind of on a roll here. Right here, 3/8. And we can make these equal. Then we look at the separation distance from here to the middle. Right there, 1.75. And I kind of like how it recognized that it was on the dotted line. Maybe that was what I needed to do early on. All right, let's try the hole by doing a cut like this and pick all 3 of those shapes. Here it is. And there it is. It's doing overkill on that. We can just say through all if we don't want to do overkill. Got the 3 holes there. And it looks like the fillets are 1/8. Okay, now let's see. Is there a way to find this thing? It's under modify. Okay, so then 1 divided by 8, which is also the 0.125 that we saw. So right there and right there. Okay. Anything else? How about some more of these holes? So we're going to place these holes on this surface and drill them all the way through. We need arbitrarily spaced here some holes, not, I guess they need to be lined up this way. That would be good. Okay, and then we need to make them properly sized, which would be a 1/2 inch. Just make sure all of those are equal. So right here and then there and there and there and there. Separation between these is 1.5 inches. Let's see if it recognized that the top and bottom um, holes are aligned. And it did not recognize that. So what we can do here is if we see that the Y direction is this way, we can line these up vertically like this and vertically like that. Okay, so now we need some hole placement left and right. You can see it's 3/4 of an inch. Okay, got a little rotation there, so that means we need to make these horizontal. There. Okay, was that the wrong horizontal? Oh, I hit vertical instead. That's the horizontal. And then this one also is still purple. So if we look down here, we got 2 dimensions needed. Let's see what they might be. Did we space them vertically? It says a 1/2 up and a 1/2 down. So we'll just use that. So 1/2 right here. Now they look like they're fully constrained. And notice that although I have them on this plane, I can still cut through the entire thing. I just kind of use that one sketch to make everything nice and symmetric. We're going to go all the way through, selecting all of these things right here for the cut. So sometimes we can just take advantage of the fact that there's nothing back behind there that we're going to drill through to make it look like this and make quick work of it. I think that's all I have on this one. So I'm going to hit save. I might come back and do these threads in a moment after I do this cap screw with the threads as well. So going back up here to the file name, we're going to go to the screw. Oops, don't want to delete that. And we're making a new part. And like I did before, just save a new with the proper name right away. You can see there's going to be a revolve by the way they have it drawn here, I think. Yeah, it looks like we got it, just a revolve. And so they're saying just make it a shape over here that has a rectangle and then some arcs. So we'll start with the rectangle and we need this one. And you see it's highlighted up there. I'm going to put 0.75, hit the tab key and type in 0.375 divided by 2 for this one over here. So hitting the enter key, I have it placed down there. And of course, I put it in the wrong uh, quadrant. I really wanted it to be up the other direction. So why did it decide to do that? Maybe it's the directions that I had it placed or had it drawn or pulled. 0.75 and oh yeah, you know what? What we can do is use our special line called the center line and go all the way out there. Click on that line. Let's make sure it says center line. Gives it that dotted line appearance because that's going to allow us to go between those two. That didn't seem to work. But you're supposed to be able to go here and then there. Now you can see it's doing it properly. 0.375. So now it looks like the diagram over here to the right. That always helps with a revolve when you can put a center line in there. I should probably make that part of my best practices in order to do that. As you can see up here, we're going to go up a little bit, over a little bit. We're going to have an arc. And then what else do we have? We're going to come over here a little bit, go up, and then over. And then I'm going to try to lock it into that distance right there. Although I didn't really need to do that. I really should have gone up from there. Let's just finish this off and make sure we get everything nice and fully defined. It's hard to know exactly where the center of this arc is. I think I see a point right over there. It's kind of telling us that it's there, but I don't really um, see a radius from that point. So what we can do is just say there's something that exists between, okay, let's do the 3-point arc, is it? Yeah. Okay, and for the 3-point arc, you go first and then end, and then you just do the middle like that. Now, we didn't really need this one right here, so I can delete that one. And what I really needed was this line that goes back this way. Okay, now I wonder if I left a line in there somewhere. I'm going to delete this one because I feel like I left a line. Oh, it actually did. Okay. Control Y to put it back in position. Did not let me do that. That's okay. Just do it again. We want this entire line to go from beginning to end. Okay. It's not letting me lock into that position very nicely, but that's okay. We're going to do it using the vertical alignment. We want this dot and that one to be aligned. And yeah, I guess that's it. Let's see if these other constraints are going to give us what we need. Oh yeah, now I can see that circle. Now we know that are the center of that circle. We know that this is actually going to be over here in a moment. Let's go back to our dimensions where we're measuring from here to the center line out like that, 0.375. It's still there. And then do we get the same thing here? Sure. Okay, so those are nice things when that happens. Out here, they're basically giving us the diameter at that point, which is 0.563. Okay, I didn't like how that went down this way, but we can try to pull it back up to make it look more like what we're trying for. We see a dimension of 1/4 inch right here. It's getting less and less purple in there. We know that the opening for our flathead screwdriver is going to be right there. It wants to be 0.047. Yeah, okay. So that's this right here. And then we got two more dimensions, and that would be from this point to the origin. It's going to be 0.188. And then the length of that line needs to be, whoops, okay, not that one. So we will delete that one. Let's go from the origin all the way over to here. Now, it needs to be 0.313. All right. Now, the other thing that we need to do is make sure this is coincident with that. So let's see if it will let me do a coincident. And then that locked everything in, and now we're fully constrained. We can go about our revolve. And I just like how it's supposed to automatically do that, but it really didn't. And it recognized something about the axis right away. That's good. Okay, now I'm confused now because, okay, okay, first create a revolve feature for the profiles shown. Okay, and then we're going to have to perform that cut next. Okay, well, I thought it might be able to handle that, but of course, shouldn't expect that necessarily. Let's go back up here to this one and see if there's any way we could now use that initial sketch to perform a cut, because it's not going to be a revolve. Okay, so let's do an extrude, and we need to look at the sketch that we started with right here. Can we then just start making a sketch from that? If we make it visible just for a moment, we might be able to do an extrude cut. I just don't think we're going to have enough here. There's just not enough in there. So when that kind of thing happens, I want to dig down into the part to get a better view. So half section view going through that sketch line, or that sketch rather, is going to be a good choice. Because then we can see that part of it right here. And if we face that by right-clicking and say making a new sketch, we can just basically make a rectangle that goes from here to there. And then I think we can just extrude that all the way through as a cut. Now, of course, we want to do it in both directions. Right there, we want to do a cut, and we want it to go through all both ways. And look at that. Screwdriver, a slot is now in place. Good. Now, how about a chamfer on the end to make that bolt easier to go into the threaded component? So we will do a modify, let's see, chamfer. And is that 1/8? Oh, need to have 1/32. And so we put that right there. Anything else we have in here? I don't think so. We can go back and take that sketch that we had initially and hide its visibility, invisibility, and then just kind of maybe look at it this way. All right, let's save that. Make sure it saves in the right directory. Is there any other parts? No, there's no other parts. Let me pause the video and then we'll come back and do the threads on those. They're going to be cosmetic threads. All right, so as you see over here, we have two options for making threads. I like to make the real threads that are using the coil tool right here, but there's also a thread tool, as you can see right here. So we're going to just use cosmetic threads and let the machinist realize that we're going to put threads in there. And do they give us any details about those threads? I don't really see any, but it needs to be made up with the threads that are here. And you can see it's 3/8 inch, and this 24 means 24 uh, threads per inch. Let's see if we can pull that off. So let's go full screen with this so we can find all of our tools. We normally do a triangular cut and we put a real thread in there, but now we're going to get lazy and put some fake threads on there. And as you can see here, it's picking the size. That's 3/8 of an inch for us. And this is, you can see 16 threads per inch, but we want 24. And it's just a lot easier, right, than having to make the threads for real. It's just cosmetic. In other words, it's just painted on, and they're not really real. Now we can go back over here to where these holes are going to be on this base plate, and then click right here and say, all right, let's put some threads in there. And hopefully it did not remember that it needs to be the same size. Now, if we go up here, I thought it would let us pick the same one again. Can we see in there? Yeah, I'm not sure why it didn't let me select both of them at the same time and make them the same, but now they are the same. Let's click Save and begin our assembly. So we're going to place this first part, which is the base plate right here, and we're going to right-click and say ground it at the origin. So that's going to be the first part. Then we can kind of pull this over like this and make the assembly look like what we have right here. So let's bring in, oh yeah, it's got this block down there too. It says follow the instructions in chapter 14 for that block. I think I know what those instructions are, and it just basically says to make a new part and just make a block. And then it's going to automatically resize, I think. So we will go down to this one and just make a random block that's not sized at all. Just like that. No dimensions. Then extrude an unknown amount. Looks like it put 1 inch in there anyway. And we'll just save this one as block. Okay, so we'll put that in at the end. It's something that's supposed to mount to, I assume. So let's go back over here to the assembly. Do we already have the name of it there? We do. Okay. So let's go ahead and place the block in there, or maybe let's go for, what is it called here? The bearing, and put it right up here. Let's do a couple of things for the alignment. We're going to say make a constraint so that if we zoom in on this, we want that axis. See the two circles in the line right there? We want that one. And we need to find two circles in a line down here as well. All right, kind of clicked there for us, but it's not going to be enough. As you can see, we'll be able to move it around like this and then up and down. So we need two more constraints in there. So how about we just orbit over here and do another one of those constraints, recognizing that we have to do a two circle axis there, two circle axis there. And now all that's left here is to realize that the only thing that we can do is move this up and down. And we really want to lock that in for the assembly. So now we're going to do a constraint. And we want this one right here. Now flush would be if they're going in the same direction, but these are basically going to be touching each other. So this is the one we want. We want that surface to touch this surface. And now this is a fully constrained assembly. So it really can't move at all. Let's go ahead and put this collar in place. And you can see that what you can do is right click, and then we want to rotate around which axis? Probably the Z axis, and maybe at 2 times to make it work properly. Yep. And then we do a constraint to make the two circles, and then we realize that that's not going to be enough because it can still move up. So we're going to be doing a surface to surface constraint, like we want this one to touch that one right there. Okay. Now I think actually this can rotate still on top of it, which is okay because they don't really say anything about that. If we wanted to see that rotation, we could come up here to the top and just give it a little bit of a texture for that. That's not a good texture. Um, Plasticized, I don't see anything there. But some kind of just kind of rough surface. Um, Probably not glass or gold. Bronze, soft tin. None of those seem to have a texture associated with them. So I'm just going to go down and do extreme and get some wood. And now you can see that it's there. You can see that by rotating this, it is indeed allowed to rotate and give us a degree of freedom. And so the way that we would probably lock that in is put a bolt there, but it doesn't look like it would hit it anyway. So it's probably meant to rotate like that. Let's hit Control Z a bunch of times until we get back to having no material right there. I guess it would be good to kind of show some different colors. But let's keep going by inserting these bolts in there. So let's place this one. All right, this will be one of them. Now let's right click cleverly and rotate around the Z a couple times and put it there. And how about another one over here? And you know what to do next, right? You want to have these two circle line up with. Now you got to come in there so you can see the two circles. Otherwise, it's just not going to work. So you really got to get right to that point there. Okay, and we'll handle the other part in a moment. Now, where did the other bolt go? Oh, it's over there. All right, so do the same thing here. Zoom in a little bit. Constraint, two circles, and then click OK. Now you can see that these can be moving up and down, but you know what to do, right? Let's make a surface constraint and do the bottom here and the bottom there. Now it's right in place, and it's also a little bit exposed, as you can see. You can click apply there so you can apply the next one. Right there. And way down in there. Click OK, and we have those in place. Coming back to this position here, is there anything else that we need to do? All right, so let's pull this up. It does show that line there, and I think you can show that one by going View and then Visual Style and then doing the edges like so. And what else? It's got these arrows on here for the template, and it also has the block. So I've hesitated long enough on that block. Let's put it into place and let's see if it's really going to do what we expect. And that would be, it's my understanding that what you can do is put a constraint so that this surface and this surface are not, let's see, get over here so you can see it. We don't want them to be mated like that. That's mate, as you hover over it. We want them to be flush. So we really want it to go that way. All right, now let's apply that one and let's do the same thing for these other surfaces. Like, see that one right there? If you look through the part, you can kind of see that surface there. And we want it to be, this time we want it to be mated against this one right here. So now it's kind of, going down. Then do the same thing, but oops, okay, leave it over there. Then we say apply. Now we want these two surfaces to be flush. So there and there. And then we go around here to the other side, and we'll see if it'll stretch for us. I'm hoping that it will allow us to stretch it. Because we hit apply on that one, and then we say I want this surface and this surface right here to be flush. Okay, so I think it didn't allow me to do that because it didn't have the correct width on that. So I think that was 3 inches. So we're gonna hit cancel right here, go back to the block, and then try to guess which surface it was that needed to be 3 inches. So this is guess to see if it's going to be that one. And then hit that and then save it. That change should roll forward to our assembly. You can see it's right here. Um, but somehow it lost all those other constraints I had in place. So we'll try that again. Let's see if we can do constraint, this one and this one. Okay, it all came back. And then apply. Oh, actually, it already had that in place. It was, I forgot. It was playing, it was rolling it forward. Now, the next thing we want to do is click OK there, accept relationship, and then add another one. And I think they want this one to mate with this one over here, at least as far as the book goes. And I guess we'll just say accept relation. Nope, it didn't quite allow us to stretch it. So I guess we got to figure out how long it is. No, I don't think it should go there because it's a corner here and it's curved right there. So let me just take a look in the book right quick on this, chapter 14, and see what it says there. So we go through here and we may need to make sure we follow the instructions as far as that block goes. So going through everything we've done so far. Okay, we did this one here. We've already done, we've learned about those. We've done that. Let's see if we can get down to the block. Yeah, because we've done a lot of work already. All right, so there's our block. And I guess it didn't say, it says arbitrary size. We did that, 2-point rectangle. And then we extruded it. I wonder if it's because I gave it a dimension on that extrude. But I think that all we're really trying to do, though, is just put it underneath there, right? It's just an arbitrary block. It says you can pull this face here and put it on that one, but I think we have, um, oh, they want it to be the middle of that right there. Let's not worry too much about that. I think we've done enough here. It says go to the middle of that plane instead. But let's not worry too much about that. It's just an arbitrary block. We could play around with those distances and figure out what they are instead. So let's see if we can figure that out by looking at the base plate right here. So I'm gonna do it that way instead. So what you can do is go over here and you can say inspect and measure, and you can measure from the center of this one all the way over to this edge, and you see that that distance is 5.523. And so going back over to the block, we might just say that this distance that we need along this axis, right here on our sketch. Okay, yeah, that would be it. It's 5.523. So there's a number of ways of making this happen. Then click OK. Probably will have trouble with that symmetry when we go back over here to the assembly, but let's just see what happens. Yeah, it had a little trouble with the symmetry because it expanded in both directions. So we just make these two not mates, but flush. Okay. And it says we've already really done that before. It's just resetting. We have finished our parts, and so now we make our um, final thing, and that's going to be our drawing. And let's see if we can use the SFA template. So just to remind yourself, if you're on a computer that doesn't have um, the SFA template installed on there, we can go over here to our content and see if we can quickly find it in the sidebar. There it is, right there. And so it gives you some instructions to go over to this directory and put it there. So I'm going to try to do that. Going over to Windows Explorer. And let's make sure I have a directory like that since I'm using 2026. And so there it is. And we also have the English directory. And it says download this template and put it in there. So here is the download, copy, and then I'm going to put it right here. But then also it says to put it in English. And let's just see if it automatically now shows up as a template that we can use in Inventor. So new, and there it is. And so we hit create. And now what we want to do is possibly save it. We'll see what file name we're supposed to use on that one. Right up here, we've done all of this stuff. Now we're just down to this drawing PDF file. So now what we're going to do is actually just save it as a drawing first, and then we'll print it as a PDF file. File, save as, keep it in the chapter 14 directory as a drawing. And let's insert our assembly if it will let us do that. So let's see, we want to grab the component first of all. So we want to, let's see, our base is going to be select document, the assembly. And we want it to be this view right here. And it's really going to be the only thing that's there. And we probably want to make it bigger. So how does that look? Or how does this look? I guess that's kind of okay. But just in case we need a little extra space for labels, let's do this. And then click OK. Now, let's see if our next option, see if I can find the right page here. Okay, we want to put these annotations in place, and then maybe make this table over here using the instructions in chapter 14. Okay, so where is the PDF file? Is it right over here? Seem to have misplaced it. Okay, so we got this one in place. We heard that gap already. We put it right here, like it said, and then we're going to edit the sheet, but we've already picked our sheet to be the SFA template, so we don't need to worry about that. We'll do parts list. Yeah, I guess we can actually do that at this point. Let's see, a parts list is down on the drawing annotation. So we'll try that. Let's go ahead and save it. And then we're going to go to annotate, and there's our parts list. And it's hopefully going to put everything over here when I click OK. Now, wonder why does that. Okay. Okay, so I want to enable the BOM view, put it right down there. And so it basically tells you how many of each object you have, which is kind of nice. And then this description, you don't really need this column. I wonder if it'll let you right click and say, hide that column. Let's see, group settings, column. Is there a way to delete that column? Because we don't really need that one. Hmm. Let's see. Try it one more time. Table layout. No. There's something about that column chooser. Okay. So we don't want the description, so we can just remove that one, click OK and apply. That started to look really good. Now we want these objects to be filled in automatically, and you remember how to do that one. Going over to the assembly, right-clicking on it, looking at the eye properties. Oh, it appeared way over here on my other monitor. Summary, and then for the title, um, let's see what title we are supposed to use. Jeff Support Assembly. And let's put it in all capital letters. Not sure why they didn't do that. And for the subject, I think what we do is we just put the units in there the way we have the template set up, and then we can put our name in there as well. If we apply that and then save it, hopefully that shows up on the drawing. And you can see it did right there. Everything is looking good. And so to finalize it, we could make it, slightly bigger, and that scale would be down here. So can we change the scale at this point? Can we like edit the view? So if we go here and say edit view, can we get something like a 3/4 or something like that in there? Let's do a 3 divided by 4. Okay, I just randomly guessed at that and got pretty close. Okay, so then we're going to put labels on these, and we're going to use the bubble labels if we can find them. It's going to be under annotate, and this is the leader. We really want the one that has the bubble in there. Okay, this whole thread. Welds. Oh, balloon. Here it is. All right, so we're going to go over like this, and that one says that it's object 3. So I guess you have to hit balloon, click on it, and then right click and create. I put it on the side over there. That's not good. But you'll see down here, it does say color. So that's really nice that it automatically recognized that it was object 3 in my list. Okay, and then so I clicked twice to see, and if I hit continue, it'll let it see if I can get it to leave it there. So the order is click, click, and then right click and say continue. What a pain, right? And then click, click, right click, continue. So now we have 1, 2, and 3 up there. And then we can go ahead and put the block in place and the 2 screws. So click, click, right click, continue. Click, click, right click, continue. Beautiful thing there, right? So then let's print this out as a PDF file. So just like that, Microsoft PDFs. Make sure you say best fit, otherwise it will probably not work very well. A good preview wouldn't hurt either. And I guess the only thing about doing that is how do you get back? Okay, this was not a part, so we can close that one out. Um, yeah, okay, so I guess we just say print right here. All right, make sure it saves it as PDF file. put that in the same directory, possibly. You could do something like this, where you go into Inventor, chapter 14, and then you can do star dot star to look at the file names, because we want it to be this one, but not with an IDW, but a PDF. That's just a way you can cheat a little bit of getting the file name properly done, so that then you can upload that into D12. All right, that's all I have for this video. I will see you in the next one.